dividing decimals by 10, 100 and 1000. So if in your big book you can write the heading Gwaith dosbarth and then multiplying and dividing decimals by 10, 100 and 1000 and today's date. So first of all, if we look at the general rules. The general rule, if you're multiplying a number by 10, whether it be a decimal or a whole number, we actually move each digit one place to the left. So the value becomes 10 times bigger. Multiplying by 100, we move each digit 2 places to the left. And then multiplying by 1000, we move each digit 3 places to the left. Sometimes people do think that it's at the decimal point that is moving. However, it's really important to understand that the decimal point is fixed and it is actually the numbers or the digits that move. You can, however, use the trick of moving the decimal point in the opposite direction if that helps you with getting to your answer. Some other points here and some mathematical facts that we need to know and can help us with calculations. Multiplying by 0.1 is actually the same as dividing by 10. So we'd move each digit one place to the right. Multiplying by 0.01 is the same as dividing by 100. So you're moving each digit 2 places to the right. And multiplying by 0.01 is the same as dividing by 1000. So in this case, you'd move each digit 3 places to the right. Or if you were looking at the decimal point, that would be going to the left. But remember, it's the numbers that always move. So side heading examples, 8.4 times by 10. So if you look here, in our units column, and then we've got the decimal point, and then we've got our tenths. So in our units, we've got 8 units. Well, we know that it's moving one place to the left, so it's going into our tens, and the 4 is also moving one place to the left. So we end up with 84. Next, 2.35 times by 1000. So if we were multiplying 2.35 by 1000, our 2 is going to move 3 places to the left. So it's going to go 1, 2, 3. So it's going to end up there. Our 3 is going to follow suit. So it's going to go 1, 2, 3. 5 is going to follow suit. 1, 2, 3. And then our decimal point is fixed in that position. Therefore, we've got a gap here which we need to fill with a 0. So it's 2,350. Looking at our next example, 404.7 times 100. So if I write that out underneath here, 404.7. and our decimal point underneath there, because our decimal point is fixed. Multiplying by 100, we know each digit is going to move 2 places to the left. So starting with this 4 here, it's going to move once, twice, and end up there. The 0 is going to move once, twice. The 4 is going to move once, twice, and then our 7 is going to move once, twice. So again, we've got an empty box here that we must fill with a 0. So our answer is 40,470. Looking at our next example, 50.2 times something equals 502. Well, we started with 50.2. Our decimal place point is in the same fixed position. And we end up with 502 as our answer. We can see here that the 5 has moved one place. It's moved over to our hundredths to the left. Therefore, we must have times by 10. Looking at example 5 then, 27.3 times something equals 27,300. So So again, if I write in 27.3 and then I pop in my 27,300 and then our decimal point. We can see the 2 has moved 1, 2, 3 places to the left. If the number, each digit has moved 3 places to the left, so has the 7 and so has the 3. We know that the value must have been times by 1,000. Last example then, 897.5 times by something equals 89,750. So if we write in 897.5, and again our decimal point remains fixed, and our answer is 89,750. This time we can see the 8 has moved 1, 2 digits. The 9 has followed suit, 1, 2 digits, and it's going to the left. If they move 2 places to the left, we know the answer, the number must have been times by 100. So, moving on to division. Well, division is the opposite. So, rather than moving to the left, your number will be getting smaller and they will be moving to the right. So, if we divide by 10, move each digit 1 place to the right. Divide by 100, move each digit 2 places to the right. Dividing by 1,000, move each digit 3 places to the right. Again, it's important to remember it's the digits that move. However, if you did want to think of it as the decimal point would be jumping to the left. If we look at these facts here, dividing by 0.1 is the same as multiplying by 10. So our digits would move 1 place to the left. Dividing by 0.01, same as multiplying by 100, each digit moves 2 places to the left. And dividing by 0.001 means it's the same as multiplying by 1,000. So we're moving each digit 3 places to the left. So continuing with some more examples then, but this time for division. This time we're starting with 96.6. Decimal point remains fixed, and we're moving each digit, dividing by 10, 1 place to the right. So the 6 is going to move here, the other 6 is going to move to our tenths, and our 9 is going to move from our tens to our units. We end up with an answer of 9.66. Moving on to the next one, 3.43 divided by 100. So if we pop our decimal point down, this time we know that each digit moves 2 places to the right if we're dividing by 100. So this 3 here is going to move 1, 2. The 4 is going to follow suit, 1, 2. And then 3 is also going to follow suit, it's going to go 1, 2. This time we've got the 2 empty boxes either side of the decimal point, so we need to add in 2 zeros. Therefore our answer is 0.0343. Next, 17.05 divided by 1,000. So if we write that in, 17.05, and it's being divided by 1,000. So if we pop our decimal point there, divided by 1,000, we know each digit moves 3 places to the left. So if we start with a 5 here, it's going to move 1, 2, 3, and end up there. The 0, 1, 2, 3, the 7, 1, 2, 3. Once you've got that end digit, we know everything else is going to follow. 1, 2, 3. Again, we're going to have to pop in 2 zeros here either side of the decimal point, as we've got empty boxes. 0.01705. So next we've got examples where we need to fill in the missing value. So we're starting with 234.5 and we're ending ending up with 23.45. We can see here that each digit has moved one place to the right. If it moves one place to the right, it means we must have divided the question by 10 to get to our answer. Looking at the next one here, 7,568.8 is our starting point, and we end up with 7.568. We can see the 7 has moved 1, 2, 3 places. The 5, 1, 2, 3 places, and the same then with the other digit. Oh, sorry, we're missing an 8 there and there as well. So our answer is 1,000. We've divided it by 1,000 to get our answer. And then, example number 6, 234. So we're starting with 234. Remember, if the decimal point isn't in the question, it comes after the units digit. And then we're ending up with 0.0234. So our 2 this time has moved 1, 2, 3, 4 places. This moved 4 places. What do we think would be the answer this time? 3 places is 1,000. This one is actually there to stretch you a little bit. It would have actually been divided by 10,000.